Hi everyone, this is Mahmoud. I'm a postdoc researcher at the Sanad Lab at New York University, Abu Dhabi. I'll be presenting our work where we try and look at the effectiveness of using LLMs to do Python library migration. This is originally Mohayeminul Islam's work, but unfortunately he couldn't be here today, so I'm presenting on his behalf. Mohamed just defended his PhD at the University of Alberta. And also collaborating on this work is Ajay, Kumar, Ildar, Akhmetov, and Nadi. So, what is library migration? This is a process that a developer would go through when they want to swap one library that they use in their code with another library that does similar functionality. So we call the library that they're using in their code the source library, and they wanna replace it with a target library. Let's take an example. So if you look at this diff view, you can see this is a library migration from the request library to the AIO HTTP library. Both libraries provide functionality for HTTP requests, and with the AIO providing asynchronous calls. So let's look into what does it entail to do this migration. So the first thing the developer need to change the import. The next thing they need to change the name of the status field. So the status field name is different. And if you can see, the request.get function got replaced by two other functions. And then the developer had to have the asynchronous, some asynchronous and await keywords. So as you can see, it does take several kind of code changes, and to do this manually can be time consuming and error prone. The developer need to understand both libraries. He needs to do API mapping to kind of know what functionality map from one library to the other and actually do the code change. So in the literature, technique that were looked at automating this process had either stopped at API mapping because it's a complicated multi-step process, and the one that do attempt full automation, they don't support the diverse type of code changes that come at play when you do a library migration, or they do it for a subset, specific subset of libraries. So we've seen that LLM, they are good at code comprehension and code generation and transformation, which are all upstream tasks that a developers need to do when they're doing library migration. So this brings us to the question that we ask and we try to investigate in this work is, can LLMs do library migration? So in this work, we use the PyMicBench dataset, which is also by Mohayemin and some of the collaborator on this work. So this dataset was mined from real-world Python projects. So it contains the pre-migrated code and the developer migrated codes. It consists of around 314 migration across 134 library pairs, across 300 repositories, and if you look at the different individual code changes, constitute around 3,000 code change. And the data set is annotated. So each code change is annotated to kind of describe the different aspects of this code change. And if you want to read more about the taxonomy that you use, you can read it in the paper, or maybe find me later in the poster section, and then we can talk about it. So in our process, we take the pre-migrated code, so the code that need to migrate it, and we prompt the LLM with this code and give it the source and target library and ask it to migrate the code and prompt it to migrate the code. And then we do two different type evaluation. Recall in the Pymic bench, we do have the developer migrated code, and this is what we consider as a ground truth. So we do compare the LLM migrated code with the developer code. We do automatically do an exact match, and for those changes that was not matched, or the changes of the LLM, we do a manual validation to try and see are they viable alternative or not. And then for the repos that has unit test, we run the test on the developer migrated code and on the LLM migrated code, and we compare the status of those tests. So we see which test passes with the developer migrated code that actually passed with the LLM, and we consider this as the test evaluation. We run our investigation or pipelines through using Llama 3.1. So we use three LLMs: Llama 3.1, GPT 4.0 Mini, and GPT 4.0. So, what was our finding? We found that yes, to a certain degree, LLMs are efficient in doing library migration with some restriction and to a certain degree of efficiency. And we found that GPT 4.0 had the best correctness scores on a migration level, so that's looking at the full REPL migration. It was able to migrate 57% of the data set when we compare it to the developer migrated code, and it was able to migrate 64% when we use the test evaluation. Now, on a code change level, because a migration could be not fully correct, so it's not a full migration, but there's still some meaningful and helpful code changes that the LLM did migrate. So we compare on the granularity of the code change, and we find that GPT-4o was able to migrate 94% across all code changes. And when we compare it with the taxonomy, like across the different categories of the code changes, we find that it was able to migrate at least 77% of those code changes. So our work was investigating the effectiveness of LLMs in doing Python library migration. We've shown that they are effective to a certain degree, and we did look at the different categories of code changes that they're good at or not good at. Please scan the QR code to access our artifact, and then you can go to our website to learn more about what we do with the software analysis and developer support. Thank you for listening.